So here's the review, which is to write a program that asks for the player for two numbers. Let's just do that part first. So here I have a simple empty program that does nothing. And the first thing I want to do is I want to write a for loop that just prints the numbers between 2 and 8. Because I think that's the easiest thing to do. So if I just do, I'm just going to print a for loop that I know goes from 0 to 10. It's going to do it 10 times, sorry. And I'm just literally going to write this, because we did this last week in class. And I want to start off with a loop that I know will compile and print out a result here that I remember. So I just wrote a for loop that writes out numbers from 0 to 9. Cool. If I want this to write out numbers between 2 and 8, including 8, that's how I would do it. So I just want to get this thing working just with hard-coded numbers here. So I see 2, 3, 4, 5, 6, 7, 8. That's the first step to adding all those numbers together. So before I even get to adding those numbers together, instead of counting from 2 to 8, why don't I ask the player for what numbers they want to type in? And I'm just going to make two variables called start and end. And I'm going to read those two numbers in. So I will do 1 and 100, right? But it's still counting from 2 to 8 because that's what I have hard-coded in there, right? So how do I have it use those numbers that I type in? So the nice part is that you can replace this number here and this number here with variables. This dictates where I start. So I'm just going to type in start here because that's the name of my variable that I created. This indicates where I end, so I'm going to type in end there. I'll run this, and I'll do this again. Type in 1 to 100. So you can see here it ran and printed out all the numbers between 1 to 100. All right. Then finally I need to add those numbers up together. So if I want to add it up, I have to have a variable called sum, which I'm going to start off at 0 because it needs to get initialized. If I just take sum and I add I to it, I is equal to whatever I start at all the way up to the end, going up 1 at a time. That's what this loop says. And at the end I can say like the final result is okay. So now if I run this and I do 2 and 8, the final result is 35. How did I get that, right? So let me just step through this with 2 and 8 just to show you guys what the variables look like. So I'm going to pin some of these variables here. So I'm going to pin start up here. I'm going to pin end up here. Right? So those are what start and end are at. So I is currently this crazy number here because it hasn't stepped into loop yet. If I step one time, I goes equal to 2, right? So I is equal to 2 because that's what start is. Sum is currently 0. If I step one more time, sum is now equal to 2. Okay, cool. So it goes up to the top. Remember the way the for loop runs, it runs the body and then increments it. So I will get 1 added to it, so now it's equal to 3. You're going to plug 3 back into sum, so now sum is 5. And this repeats over and over again all the way up until I'm at 7 now. So I add 1, 8. So I add 8 there. Now it's going to go all the way back up to the top and see if it still needs to run. But before it checks to see if it needs to run, it'll add 1 to it. So I will become 9 and see if 9 is less than or equal to 8, which is false, which then causes you to exit. All right? Two numbers, 2 and 8. So let's do the optional part now, which is to actually create a string of values that print across, because what I really want is I want to see out like I and then this, right? And some of you guys have run into an issue where this works great at first, oops, I have this thing here. If I enter like 1 and 100, it adds them all up, but there's one extra plus sign at the end. So it's almost right because I'm writing out the plus sign in between all the numbers, but I don't want to do this if it's the last number. So there's lots of ways you can solve this. I'm going to show you guys some of the ways that I can solve it. I'm going to show you 3 different ways to solve this. The first thing is to set up an if statement. if I is equal to end, what you can do is print out just I. Otherwise, print out the plus. And what's nice is that you can just say equals to here. So this if statement is set up now so that, this if statement is set up now so that if I is equal to the end value, don't add the little plus on the end of it. Otherwise, run this line of code here. So if I put a breakpoint here, I enter 2 and 8. So is 2 equal to 8? No. So it will not run line number 16. It jumps to 20. So it keeps on doing this. It keeps running this version of cout all the way up to when I is equal to, oops, I missed it. Set 6, 7, and here I is equal to 8 now. So now this branch will go into this version of cout, which will only print out the number and not the plus sign. And then finally, after it's done outputting, it prints out the equals 35 because that's what I have on the end. So this is one way to do it. Another way you could do this is you could make a string variable that is equal to what you want to print out. I'm going to call it the suffix plus. Okay. What you can do is you can set that string variable equal to nothing, and then you can just print out suffix at the end, like that. This is me using a variable of what I want to add on to the end, and I'm changing what I want to add on at the very end. Oh, and if you do that, you have to include string at the top. And this is the other way. Basically, I always print out something. Sometimes that thing is going to be blank. So if I do 2 and 8 now, you can see here now it's adding those plus signs on the end of it. I can inject whatever I want to in here. This can be like, I don't know, 2 but, 3 but, right? And I can replace the last one so instead of pluses here, I have buts, and then at the very end, I have done, exclamation point. So that's another replacement. And then finally, the third way you can do this is using a new operator, which I haven't shown you guys yet up until now. It's called the ternary operator. Instead of writing an if statement like this, where you have an if-else statement that does 2 different couts, like this, you can combine this whole block of 8 lines of code into a single line. This whole thing can be dumped out into a single line if you want it to be. Because you can use what's called the ternary operator, and I'm going to get into more detail about this later, but I'm going to show you how it works anyway. If I equals end, and you can replace that whole block with just this right here. Notice there's a question mark here. This is basically a one-line if-else statement. This says if this stuff on the left of the question mark is true, run what's on the left side of the colon here. If this is false, run what's on the right side of the colon here. And it does this all in one line. It does it inside one statement, and this is very useful in a lot of cases where you don't want to do an if-else statement that takes up 7 lines. This lets you do the same exact code in one line, which is nice and convenient. So now I can do 2 and 8. Oops, I flipped it. No one caught that. If I is not equal to end. If I is not equal to end, print out the plus sign. 2 and 8. You can see here, same exact result, all in one line of code. All right. So that's all the different ways you can solve this. And that's using a for loop in a lot of interesting different ways. So let's do a little bit more practice with for loops here. Okay, so I want to talk a little bit about objects in C++. So this is going to be a bit of a lecture. So all the way up to this point, we've been dealing with variables in C++ that are like single values, like it's an integer, it represents a number, or it's a character, represents a letter, or it's a bool, it represents true or false. And you can only get really so far by using those things. One of the best parts about C++ is that you can make your own variable types. You can make your own variables, and you can make them be whatever you want them to be. So you can make equivalently your own version of whatever integers are. And what's nice is that the reason why this is important is because sometimes you want more complicated variables. You don't want just a single number. Maybe you want to have two numbers together, right? A perfect example of this, like a player in an RPG. Why don't we make a new variable type called a player, okay? I want to make a new variable type called a player because I know that a player is comprised of a lot of different properties. A lot of different things make up a player in a game, like Call of Duty or Fallout or Skyrim or Final Fantasy or Diablo. Let's just pick some of the things that describe a player and see if we can combine those things into a new variable that we'll create, okay? So what are some things that define a player in like an RPG? I'm going to start you off with like health, strength. What about mana? Okay. Armor, sure. Movement speed, level, player name, class, equipment that they have, race, gender, position in the world. Am I alive or am I dead? I've always used that one.
Grounded.
What's that, grounded?
Is grounded.
Sure. Am I in a party or not? Am I currently fighting in combat? Am I in combat or not?
Sure.
Am I crouch? Am I standing? Am I running? Am I prone? All these things define what a player is. And what's nice is that C++ will let you create a new variable type that has all those things in it. And just like how in Windows you make folders within folders to describe like where your files are. Like imagine if in Windows, right, every single file in your computer was in one directory. Every single one was in one folder. Okay? That's basically what we've been doing up to this point. We've been putting everything into one folder. C++ essentially lets you break apart and describe things inside their own little folder, like their own little category. So imagine you had a folder inside your Windows directory that was a player folder. In there would be files related to their health and their mana and what weapons they have. And we have that capability. So this spacecraft, for instance, has a few things that describe it. One of them is how much energy it has. The nice part is that in addition to describing the things that define a variable, so this guy is making a new variable type called a spacecraft. All right, that's basically, it's just like an integer or a bool or a string. He's making something called spacecraft. And it has an integer inside of it, and he's going to call that thing energy. He's just saying that represents energy, okay? Something else you can do is you can associate things that variable can do, okay? So this is what we're going to go over today, which is how to not only store additional information in a variable that you create, but also to give that new variable that you create, the new variable type that you create, useful functionality that people can use when you're making your game. And when I say like people can use, I mean like another programmer can use, or even you can use. Because again, think about if you had every single file in one folder in Windows, all your executables would be in that file. folder, right? So if you want to find out like where to run Internet Explorer, you have to literally go in there, like find the Internet Explorer exe, and that's all the other crap that's in there, right? But it's a lot easier if you have to you guys have to browse for like your Steam games or like browse for like games that you find, go into a folder where that game is installed, right? And you run the executable that folder is in. Like if all that stuff was in the same directory, it'd be chaos. And this is the reason why this is important, because you can't just have everything all in basically one flat structure in C++. Like for Overwatch, for instance, we have well-defined basically folder structures for all of our objects that we care about in there. So when we're talking about a new variable type, there's two pieces to it. Every variable type, there's two things you can add to your own custom variables. One are called the data members, which are basically the variables that define what that thing is. So that's health, mana, am I alive or dead, am I on the ground, what's my race, what's my class, what's my gender. Those are variable types. Okay? Those are called data members. They describe the object and what it is. Then you have what's called function members, which describe what that thing can do. Okay? So this is a little bit of a weird concept because there's no real like analogy for this in like real life. I mean, but we can talk about it a little bit in the aspect of like a car maybe. That might be a good example because like it's used a lot as a describer for what an object type is. So let's just take a real world example of a car. So if we say there's two things that describe a car, there's the things that the car is, and there's the things that the car can do, okay? And those are the two ways you describe an object. This is basically an example of a function member. This is a data member. So a car has things that describe it, like how many wheels does it have? How much horsepower does it have? How many doors does it have? How much NPG does it get, right? What color is the car? How old is the car? What year was the car built in? Those are things that describe the car. Those would be equivalent to data members, okay? Let's write out some of those things. So here's our car. Let's figure out what the data members are here. So it's like number of tires, number of doors, color, year built, model, make, okay? Those are things that describe what those are. These are basically types of variables that we have. So this would be, I don't know, an integer, right? This would be an integer as well. Maybe color is made up of, so we're going to get to this. This is actually another example of a variable type that's custom. The year built is an integer. The model maybe, these are also special. We'll just call these things strings. Let's just use some strings. Okay, so what are the things that a car can do? It can turn on, right? It can move forward. It can move backwards. It can turn left. Turn right. What other things can cars do? Break down. Break up. I don't know. Accelerate. Brake. Decelerate. Honk. So you guys understand where that distinction is, right? These are, what's that? Run over people? There's two distinct things that describe a car. It's the thing that the car is, the properties that describe it, and the things that the car can do. And C++ basically lets you these are the two things that you can do with an object in C++. You can describe what that new variable type is and what that object is, so the properties that define it. And then you can also give it some functions, things that it can do. And usually these functions are just a matter of modifying the variables that exist within it. Okay, so for example, turning on a car. What if we had a bool here that says is on? That's a description of what the car is. It currently running or not, right? That's a property that describes what the car is, whether it's running or not. So when you turn on a car, all you're going to do is you're going to modify the properties of the car. So when you turn on a car, you're going to say, hey, I'm running now. Is running is true. Okay? For instance, what about the speed? I can have this thing be afloat. When I move forward, my speed will be positive, right? When I move backwards, my speed will become negative. These function members basically modify my data members. things that you do with a car modify what that car's properties are. So every single one of these functions basically modifies a property of the car in some way. Even honking. Honking is like, hey, am I currently honking or not? There could be a bool here. Horn is honking, right? So that's the relationship between those two things. And the reason why these relationships are important is because when you're making a game, and you're making like a hero, you need these function members to be written in a way that makes sense to the people using them. For instance, if I were a gameplay programmer and I was responsible for making like a Diablo 3 barbarian class, let's just describe a Diablo 3 character a little bit. So I kind of mentioned this. Maybe he has HP. Maybe he has rage. He has like level, right? What other things? Is male. What are other properties of a Diablo 3 or any real RPG character? Give me some other properties. So there's the stats, right?
Yeah, stats.
Intelligence. Okay.
Movement speed?
That's a good one. I'm going to say is alive. Maybe this one isn't necessary.
Damage range.
Okay. How about float min damage? And then float max damage? Sure. X location. Y location. Z location. Right? Because there's 3 parts of location in a 3D game, X, Y, and Z. What'd you say?
Resilience.
Resilience? Sure. It's like Dark Souls style. I don't know what that doesn't exist in, or resistance. Like, I don't know, physical resistance. All right, so this, you guys get the idea. What are some things that a character in a Diablo 3 game can do? Attack? Attack. Yeah. Use skill 1. Basically, there's all these, which are like skill-based things. You can use a skill. He can die. Serve? What do you mean?
When they're an apparition before they respawn.
Oh, really? I thought you just stood there. I think
No,
you did like...
you run away from where you're at.
Oh, that's right, because when you're respawning, you can actually go back.
Unless you're playing hardcore. Like you
He can move, right?
It's the only way to play.
So let's try to be as specific as possible. Like we don't want to like say something generic like he can farm enemies or he can like kill bosses. That's not something that he himself, like killing the bosses is basically comprised of him using skills enough, right? So these are examples of things that he does. So we're going to talk a lot more about this, but the example I'm about to jump into is describing the string variable type, because a string has all these same things. So a string has properties inside of it like length of the string. That's a good one. It also has a collection of characters inside of it, which I won't get into, but you can do things like give me the length, remove letter, remove something. You can insert stuff into strings. You can append stuff to strings. These are things you can do to a string, because a string is comprised of a list of characters. It has a list of characters. Okay? So this is a very simple data member, although in reality, like strings are actually internally pretty complex. But I want to show you guys some of the things that you can use this for, because this is basically going to build upon how we're going to use SFML to draw objects to screens. This is how video games are made. When you use something like when you're writing games, you need, like a lot of times you're not writing all this stuff from scratch. A lot of times you're using what someone else has already written. Like, how would you guys draw a circle on the screen? Now, if I asked you guys to just draw a circle on the screen, I don't think you would like necessarily just write something from the very beginning. You would actually probably look it up, and someone would tell you, oh, here's the code you can use. A lot of it comes down to, oh, well, you have to download this thing and install it, and then you can start drawing circles. Those things that you download and install are basically giving you objects that you can manipulate. Let's show you a little bit more. Keep in mind that this describes what a string is. And remember I had the barbarian up here? We had the barbarian described by this. Just because this describes a barbarian, it just describes what barbarians have and what properties they have. But every barbarian is different, right? Every Diablo 3 version of a barbarian is different from each other in some way. So keep in mind that each individual object of a barbarian will have its own values for all of these. Like each of these numbers will be different for every version of a barbarian that's in a game. Even though the description of what a barbarian is the same, every single one of those is different. It's the same thing for cars and for strings. Every car is different in some subtle way, right? Whether it's just the VIN number or the color, or the strings are different in a way that, the characters are different. Even if the characters are exactly the same, there's two copies of those things. Even if you and me both started barbarians and we leveled up exactly the same, and we had the same name and everything, we're still individual people. And as soon as I start changing some properties of me, it doesn't affect you, even though we might be identical. So keep that in mind, that's why objects are important. And every single object has the ability to use its own versions. Like if I die on my barbarian, it doesn't make everyone else die. Like it's my version of barbarian that dies. So these function members are unique to that object. Okay. The best part about these things, these objects here, is that you don't actually have to know how they work in order to use something like fire or weapons. You don't have to know how the starting system of a car works to start the car. You just turn the key. But there's a lot of stuff that goes on underneath it that actually causes the ignition of your engine. You don't need to know all the internals of how your car uses your fuel to turn your tires to make you move forward. You literally just push a gas pedal and it goes, right? That's the best part. It's the same exact idea in C++. When you guys have an object in front of you, you don't need to know how everything works inside that object. If you just want to use one of these functions, it just works. So if you have a barbarian and you just say die, it's going to just do the right thing. Someone will have had to have written the code to do that, but the best part is that once it's written, no one else has to care. Yeah, as long as you know where the gas pedal is, and as long as you know where the steering wheel is, for the most part, you can drive a car. All right, so how do you use these things? So if I had a variable, that's a spacecraft. Let's just say I had something called a spacecraft up here. My ship. It's going to give me a little red squiggly, but don't worry about it. You could do things like myship.energy. Remember the slide here has a variable called energy. Energy is greater than 10. Okay. So this is showing you guys a new operator, all right, that we haven't used yet. So spacecraft is undefined. This is just me making up a thing called a spacecraft. To use this as an example for our barbarian example here, I can do barbarian, my dude. My dude dot HP is less than or equal to 0. My dude dot. Okay, so let's use this as our example instead of the ship one. It's basically the same thing. So I kind of describe these things as an object has properties that describe it and functions that let you do things on it. If I have an object called my dude and he's a barbarian, remember this is my own custom variable type that I just made. This is just like as if I had an integer. I happen to have a variable called a barbarian. I can get data from that barbarian by just putting a dot after the variable name. So my barbarian, if I described him with just HP and a function, so let me just go back here. So let's describe our barbarian with our simple one. My barbarian has literally just HP, and the only thing he can do is die. Okay, so kind of a crappy game, but we'll improve it. Yeah, so if I want to get the HP from the barbarian, well, how do I do that? So I have my dude here. That's the variable name. My dude is the variable name. It is not barbarian. Barbarian is not is the type of my dude. So keep in mind here, I'm using the variable name here. And I know that barbarians have HP. So if I just put a dot there, I can rip out that HP from the barbarian. This is just like accessing a file inside of a folder. You can almost imagine like there's a file called HP that lives in a folder called my dude. All right? That dot right there basically lets you access whatever properties, whatever data members or function members live in a variable of that type. So in this case, it says, oh, you want to access HP from my dude. Well, what type of variable is my dude? He's a barbarian. All right, so barbarian we know has HP. Cool. That works. Same thing for when you're calling functions on a variable. So in this case, I'm calling my dude dot die. It's called a member selection operator. Lets you select either a data member or a function member. So HP selects my dude's HP, and die calls my dude's die member function. So we are going to make our own types very soon. We're actually going to go through and make barbarians and whatever types that we need. Just for now, I'm just showing you guys an example of if something like this already existed, that's how you would do it. Okay? And if I wanted to get rid of this, so I'm not going to show you guys how the intricacies of it, but if you guys are curious and you want to know how to describe it, this is what it is to describe a barbarian. This is me making a new barbarian type. All right? So we'll get into that later, but this is basically me creating a new variable type called barbarian. I can make it whatever I want to. So this is me making new variables. All right? Okay, so we're not going to use our own custom variable types yet. We are going to use a pre-existing type called a string. And strings are actually objects, just like anything else. They actually have a bunch of functionality in them. So let's show you an example of something that we use strings for. All right. I'm actually going to pull this from okay. So remember, if you want to use strings, you have to include the string header. So here are 3 different ways you can initialize a string. So we've so far only ever used this, or like that. But there's 2 other ways you can initialize it. So you have options when you're initializing variables. And in this case, with strings, you have a 3rd option that's not typically available to you. So you always have the option when you're declaring a variable to do that. Which is exactly the same as me doing this, which is exactly the same as me doing that. So this and this and this are the same. The reason why this is important is because sometimes you can pass in more than one thing when you're initializing a variable. So in this case, word 1 is initialized to game, word 2 is initialized to over. Word 3 has a comma in there. with a number and exclamation point. So strings have another way you can initialize them. They let you initialize it with a number, which is how many times you want this character to repeat. So word 3 is going to be 3 exclamation points followed by one another. So each of these things is actually a string object, which has data members and function members associated with it. Here's a neat thing you can do. You can take strings and you can just add them together. If you have a string, you can just do plus in between them. It basically sticks one string onto another. Okay. The reason why this works is that normally you can't just add two things together unless they're numbers. But string, being an object, has its own function members on it. It has its own things that it does. One of the things that it lets you do is add each of the strings together, like this. So here, the variable phrase is getting assigned to these 3 words plus together. So line number 18 uses the string member function called size. This is just like die, or this is just like fire weapons. This is just like turn on your car. There's basically a function member called size, and all this thing does, it returns you how many letters are in that string. And it returns that number as an integer. So if you do phrase.size, it will spit out the number of characters in it. So let me just show you. Let's just run this. It says the phrase is getting game over and tells you how many characters are inside. It counts how many letters are in that word. If I extended the words, that member function still gives me the correct result. It's a way to get interesting data out of it. So the way it's done is that you take the variable name, you use the dot, which is the member selection operator, and you call the function that you care about. If you're doing this in Visual Studio will help you figure it out. So watch. If I take phrase and I put a dot there, you guys, can you see this little dialog box that shows up here? This is a list of every data member and function member that lives in that object that you can call. Okay? Anything you see here, you can use. There's a bunch of options here. There's a ton of things you can call on a string that are useful. One of them is size, right there. As you start typing, it will shrink this list down to what you care about. So I type size. When you're using a function member, you need parentheses. If you're using a data member, you don't want to have the parentheses on there. The way you can tell is that there's a little icon next to these things. Some of these things will be a variable, like here. It's kind of hard to see. One looks like a little rectangle with 2 lines on it, and the other one looks like a box, which is a function. And that's how you can tell whether you need the parentheses or not. Okay. There's another way you can do this. There's another, I don't know why they have 2 exactly the same function members. You can also call length exactly the same as size. So if you want to use length instead of size, that's how you do it. All right, any questions so far? I'm kind of going through this stuff, yeah.
When it's the size or the length, on mine it didn't actually pop up with the different thing.
Try typing it in again. Start over from the dot. Type the dot again. Okay.
Oh, there.
Yeah, there you go,
Okay.
size.
Cool.
Yeah, the auto pop-up of the little dialog box that shows up is a lifesaver. Because if you think about how many possible function members and data members objects have, before you had this little thing, you basically had to either know ahead of time or look at the object and read all the source code to figure out what you could do. But now Visual Studio will actually finish it for you, which is really nice. All right. Other questions? Yes. Okay, so let's do some more stuff with function members. A string object also has some other useful abilities. Now, this is our first foray into arrays. A string is made up of a bunch of characters, right? We already determined that there's 12 characters in this phrase. If you use this little guy, so he's basically this. If you take the variable name and you put square brackets with a number inside of it, it lets you get the character at that position, starting at 0 for the first character. So here, phrase 0 means get me the first letter of that phrase, which is going to be what? Looks like the phrase is game over. So what will this print out here? I don't know, G. What if I did 3? So you have to look. It starts at 0 for G, and do 1, 2, 3 for E, right? Not only can you read out that variable, you can also do this. You can rearrange the letters. So if you see here, phrase at 0 is being assigned to the letter L. It says lame over, yep. Changes it to be lame over. Okay, so if I run this now, it should print out lame over. Oh, and this is the character position 3. Ignoring that. Changing the character position 0, the phrase is now lame over. All right? These are all the things you can do with strings, which are pretty cool. All right. So let's write a for loop. Here's a good example of a usage of a for loop. Let me just delete all the other extraneous stuff here. So remember how I talked about how for loops are like super common and use them to loop over lists of things? Well, one of the nice things you can do is using those two ideas that I just talked about, which is the size member function and the index operator, which is letting me get a character at a position. Instead of manually typing in a number here at I can just use a variable like here. So what is this going to do? It's going to print out every single character in that string. So watch. Let me break this down because this is, I think, pretty interesting. So look how it looped over every single character now. Like this. String, and I broke it out. Imagine this is not a string, though. Imagine this is like enemies that you're hitting. Okay? What if you had a list of enemies that you're hitting, and you want to go over every single enemy and print out their name? You can write a for loop that does basically something like this. So this for loop here, let's break it down a little bit. I'm going to put a breakpoint right here. So what is phrase.size? We already said it's 12, right? So how many times is this loop going to run? You guys have written enough for loops, hopefully. It starts at 0. It goes up to what? 12? Right? So it goes up to 12. So it's going to print out phrase with I being equal to 0. Does this make sense to people? I don't know if I'm like losing you guys for what that thing does. This thing is an object, right? It has a bunch of letters inside of it. And doing this lets you get the letter at a specific position. So when you write a loop like this is the magic. That's the magic right here. Phrase.size. Because what happens? Up to this point, you've just been typing in numbers, right? Like I can write this loop like this. 10. Let's not make it unsigned. This is what you guys are familiar with this, right? Writing a loop that goes from 0 to 10. I could do this. But what if I typed in a really long word? How many letters is it going to print out? Only 10 every time, right? Like 10. That loop is static. It means it doesn't change based on what I've typed in. How do I make this loop not static? I make it based on the size of the word, like this. Oof, phrase. I just replace it. It's exactly what you guys just did in class today. When I asked you to read in two variables from the player and add up the numbers in between them. Instead of having numbers that you've hard-coded in there, you're actually going to just use a variable here. The variable just happens to be a member function, though. This thing here will return you a number, an integer, that's the number of characters in that phrase. Okay? Okay. There's some other member functions you can use in strings that are interesting. What about the find member function here? Right here. Find will tell you if it finds that word, it will tell you at what position in that string that word started on. So in this case here, this thing will spit out the letter, which I think is 5. The number, the character position where this phrase starts. So if you take a look at the string game over and you count, it's 0, 1, 2, 3, 4, and then 5. So it starts at the 5th position. So that phrase.find is another member function that tells you whether some other string lives in a different string. Fun fact, for those of you guys that will ever do programming interview questions, they will ask you to write the find function as a test. In addition, after you've done that, they will ask you to write a function that lets you replace what it found with a different string. Okay? Those are two very common programming interview questions, which are to both write the implementation of find as well as write the replacement function too, which lets you replace a string with another string. And you're not allowed to use the string object type. You have to write your own. So you have to use character pointers. All right. So yeah, these are very common, but thankfully you don't have to worry about that because it's already written. So when you get to the point where you want to learn about how to write that stuff, I will go over it in more detail. All right. So what happens if you don't find it? It returns this special number called npos, which stands for no position. That npos lives in the string namespace. You guys remember the colon operator for namespace? This lets you get a number. Okay. So let's go over some more stuff. The erase member function. Basically, it lets you erase a single character, a number of characters, or everything. The first example here, where phrase.erase 4, 5, means remove 5 characters at position 4. This one here says remove all the characters after position 4. And the last one says just remove all the characters completely. Phrase.empty. This is another member function that says this will return either true or false. If there are any characters in that string, it will return false because it is not empty. If that string is completely empty, it will return true. Okay? All right, so this is an example of a string object. This is exactly the way we're going to be working with any other game object that we have, okay? Imagine this is like a barbarian, right? Just like what we had in the example. Barbarians, you can check their HP, you can tell them to die. In Overwatch, we have a lot of objects for various things for the heroes. So we have things called components, which tell you things like how much HP they have to deal damage to that component. We have things like UI components as well that tell you all the various pieces of information about relevant UI in the game. It has member functions to modify the UI or open screens up if you need it. So let's use a more closer example to like an RPG. And this is going to be the homework. So this is going to be used for the homework, sorry. So let's just run this. This is basically a simulation of a simple like RPG inventory system. And this is demonstrating arrays a little bit more. So you start off with a sword, armor, and a shield. You trade your sword for a battle axe. Tells you how many letters are in that item name. Then you find a healing potion, you add it to your inventory. Okay. In this case, your inventory max is 10. You can only have 10 items in your inventory. I think I mentioned that before, that you have to be careful if you have too many items over 10. Let's go over this in more detail here. So this is the first case of us using arrays. This line right here says, hey, just create an integer variable called max items. It's common convention to capitalize that stuff, but you could easily just call this max items or just item max. The capitalization is typically used to indicate numbers that aren't intended to change, which is why there's a constant in front of it, which means, hey, you're not allowed to change what max items is. I mean, I could change this to be like 500. That's fine. But after it's already run, you can't change it after the fact. Right? Okay. So in this program, the player's inventory is represented by strings. That's it. So it's literally just words that describe the player's inventory. One for each item that's in their inventory. So arrays are declared like any other variable, just like any other variable. But when you want to have more than those variables, more than one of those, you have to use a special syntax. So what is an array? Anyone know? An array is actually a very simple idea. It's a variable that can store multiple things. So you can have an array of integers. And what that means is that you have one variable that can have many integers inside of it. In this case here, I'm just going to delete this and simplify it. Here's an example of the variable called string inventory that has that represents one string. If I wanted to, I can make this variable represent up to 2 strings by putting in square brackets and a number inside of it. And why this is important is because now, if I want to get at, there are actually 2 strings in here. You can imagine that now, that what used to be one variable now actually has 2 inside of it. For instance, this is me having 100 inventory items. Okay. How do I get inventory item, say, 99? Like that. If I want inventory item at number 10, I do that. Okay. If I want the first inventory item, I do that. And I didn't have to make 100 variables to do that. If I wanted to actually make 100 inventory item variables without using an array, I would literally have to do inventory 1, inventory 1, inventory 2, 3, 4, etc. I would have to do this 100 times to do that same thing. Okay? Just go in here and rename these like that. Okay? But instead of having to declare each one of those things separately, I can just use the array syntax here to create 100 of those right away, easily. Questions? All right, we're almost done. This is the file that you guys are going to be editing for homework, by the way. So it's up on Zool already. So here's a clever little trick that's being used here. He's taking inventory at a variable number, and he's using a little plus plus after it. Remember what happens when you do this after? It uses that variable first and then adds 1. So what is that first line equal to? Equal to 0. This is basically what he's doing. Like that. 0, 1, 2. So he's assigning inventory items at 0, 1, and 2. The reason why he's using a variable, though, he wants to keep track of how many items you have in your inventory. So when he writes a for loop, look at what he's using as the end condition for that for loop. Inventory at I. This will give you the output. So the first thing he says is he prints out your items, and he goes through a for loop, loops over every inventory item, and prints it out to the screen, which gets you this. Right? If I wanted to, I could add another one here. I don't know. And then add another one here. Sword, armor, shield. These are very generic. Helmet. By adding it like this and running it, now when I print it out, there's my sword, armor, shield, magic book, helmet. It's actually added on my inventory here. Okay. So the final result of num items, after I've added all these things, how many items do I have in my inventory? 1, 2, 3, 4, 5. So this will be 5 after that. So it keeps count of how many things I've added to my inventory. Okay? So after looping over, what he does is he reassigns inventory at 0 for a new string. Basically swaps it out. And then he loops over it again. Exact same loop. Exact same loop. Now prints out, instead of sword, armor, shield, magic book, helmet, battle axe, armor, shield, magic book, helmet. Okay. So here's the most complicated line you'll see here. Look at this guy right here. What is that doing? So first, go left to right, all right? He's getting inventory item at 0. What is this after you swapped it for battle axe? It's the battle axe, right? It's a string that represents battle axe. Remember what we said we could do with strings? We could call a function called size on them. So here's how this thing resolves. It's saying get me my inventory item at 0, and then tell me the size of that string. If I change this, remember my second one is armor, 1, 2, 3, 4, 5. I could do that. How would I write a loop to tell me the size of the characters for every single one of those things? So right now, yeah, I'm always getting inventory item 0. Here's how you can easily write a loop to do that. Why don't I take this for loop, and I just copy it here, like that. So I just wrap these two lines in a for loop, and I'll replace this one with I, as well as this one with I. And now it'll print out the length of the string for every single one of those, like that. Tells me 10, 5, 6, 10 cells. Okay. And then finally, you can modify that when you're running. Here, you notice that he actually takes and adds one more inventory item here. The first thing he does, though, is he checks that num items is less than max items. For instance, if I try to add too many items, it should tell me an error saying you have too many items and can't carry another. What happens if you do try to access a number? What would happen here if I tried to do 99? What did I say my max items was? It was 10, right? This is actually a very bad thing to be doing. I kind of mentioned this example early on, how when you try to access something that, like when you try to use something that, let's say I had 10 inventory items and I tried to pick up an 11th one and it didn't account for the fact that I could pick up an 11th one, that's called a bug. Stuff like this can crash your game. It doesn't always crash. It's unpredictable. And it's weird for me to say that. You really can't predict. I don't know, half the time it'll crash, half the time it won't. You don't know. At this point here, I think what this thing will do in debug, it'll tell me that it can't do that. See how it broke right there? This is actually it crashing, but I happen to be running in Visual Studio. If I try to run this thing outside of Visual Studio, this is as if you were double-clicking on your executable here. So here's my executable, project 1. You guys ever see that dialog show up in the game?
Too many times.
You know why that happens? It's not always because of like this array stuff. This is because stuff like this is just an example of what can happen. If you're not careful about the size of your array and what you're trying to access to, you get unpredictable behavior. So when you test to make sure that your num items is less than max items here, this is called bounds checking. You're checking the bounds of the array. You're making sure that what you're trying to do is safe. It's actually, I can actually create unsafe behavior right now. If I do this enough times, this is undefined behavior too. This is exactly the same thing as what I was trying to do before. I'm trying to add like 13 items, but my array only holds 10. So there's two ways you solve this. One is you just take this guy and set it to some like crazy high number. It's not really a great solve, but hey, if you never have more than 50,000 items in your inventory, okay, never run into it. The problem with this is you pay for this cost in memory. You pay, your game will take more memory to run. The second way to solve it is something we're going to get into later, which is you can create an array that changes in size dynamically as you need it. And in theory, you have an infinite number of elements in that array. Why would you ever use this one then instead of using that one? Because that's the one that seems safer. That one is has performance costs associated with it. Every time you have to grow or shrink that thing, it costs you time and memory. This only costs you memory once. It always takes that same amount of memory, but it's way faster because it only does it once. All right. So let's do the let's go over the homework. So this is the homework. You're going to take this program, and I'm going to have you guys pick between 10 random inventory items that you give to the player instead of the same 3 every time. Okay? So you're going to combine what you had done before with the dice rolling to pick between 10 different inventory items. So I gave you some hints. You're going to use a for loop and loop 3 times. That's what the for loop is going to do. You're going to roll a random number between 1 to 10, and you're going to use either a switch statement or an if-else statement to pick what inventory item you want to add based on the number that was chosen. Okay? And then you're going to assign that inventory item to the array. This is basically giving like a random initial loadout to a character in an RPG. Okay? Right now, the homework assignment has 3, well, it had a lot more than 3 now. It was always giving you these 3. So the idea is that ultimately every time you run your program, you're going to get 3 random ones. Pick 10 items, like, you know, pick like broadswords and fireballs or whatever you want to create as your inventory items, do add. But it's going to be randomly choose amongst that 3. It doesn't have to be 3 different ones. It can be 3 of the same ones. Okay? And then add them to the inventory. Questions?
So we add 7 more to that list?
We create our own.
Yeah, you can use these 3 to start.
Or create 10 of our own, right?
Yeah, create 10 of your own. Yeah, you can use sword, armor, shield, and then just pick 7 more. The thing is that you can't, it's not going to, you can't do that. That is not, you can't do those 3 lines right there. That's the part your first thing you're going to do is you're going to delete those 3 lines, and then you're going to write a for loop, and then that's where the homework is. So follow the hints I give you. The hints I wrote is in order of how I would do it. So first things first is figure out how to roll a dice from 1 to 10. Okay? Look back at your previous homework, so you've done it already. You've rolled a d20 before. You just did it like for homework. You roll a d10, and then using that random number, make a big if, else, or switch statement to randomly pick, or to pick which of the inventory items you want. Okay? It's going to be a 10 item if, else, if, or it can be a switch statement too if you want to. There's going to be 10 in there, all right? Yeah, just follow the order that I give you, and that's going to be homework for next week.
Do you want it to be in a similar style as this, or is it going to be different?
Similar style.
Is, like, is it going to look like?
Oh,
this?
so yeah, that's a good question. So as far as the rest of the file, like all this other stuff, you don't need it to like do the replacement. Literally, the only thing I want you to do is print out the inventory items like this. I want you to randomly give the player 3 random inventory items and then print them out to the screen. Okay? All right. Okay.
Other stuff that we
So you guys are not allowed to use an if-else statement or a switch statement to do this.
no if, else, or switch.
You can't use like you can't use like the 10 item switch statement. What I want you to do is I want you to create an array of possible items in front and then index into that to figure out which one of those things you want.
Okay.
Okay? Like you basically have your current inventory and then you have an item pool. I want you to basically make an item pool. I think you've already kind of done this, haven't you? Like create an item pool where you have a list of possible items you can pick from, and that item pool is basically going to be an array. And that way you get that way you get a little bit more practice pulling things out of an item pool, because that's essentially exactly what D3 does. You roll a dice, randomly pick amongst that item pool, and then you get that and you put that in the inventory. Okay? All right. Okay, thanks everyone. I'll see you guys next week. I'll upload this video right now.